Within any class or method, the code between a pair of curly braces is called a block. For example, in this figure, it contains two blocks. An outer block begins at the first opening curly brace and ends at the last closing curly brace at the end of the method. The inner block starts with the second opening curly braces and ends with the first closing curly brace. So it contains two executable statements. Integer, another number equal 5, 12, and a print line, system.out.println statement. The inner block is nested within the outer block. A block can exist entirely within another block or entirely outside and separate from another block, but blocks can never overlap. In Java, a variable comes into existence or comes into scope when you declare it, and the variable stops to exist or goes out of scope at the end of the block in which it's declared. A Java's variable's scope level is its block. In this example, the outer block integer a number equal 10, so a number equal 10, a number can exist in the whole block, including the inner block. So we see there's a system.out.println in the inner block. The a number, we also can use that a number, it's valid. So in the whole method, so we can see the last statement, the system.out.println, the a number. So once the block ends, the a number cease to exist. It goes out of scope. And so let's see the inner block. The inner block, we have an integer, another number equal 512. That another number is declared in the inner block, so only is valid inside the inner block. So once it's outside the block, another number is not valid. We know a block of code refers to all of the code between curly braces. Variables declared inside blocks of code are only accessible by the code between the curly braces. You cannot declare the same variable name more than once within a block. In this example, we have an integer, the outer block, integer a value equals 35, integer a value equals 44. That's illegal because we declare multiple times. In the inside block, we have an integer a value equals 10. That's invalid, illegal. It's a redeclaration of a value outside the block. Even though it's a new block, the block is inside the outside block. The variable still cannot be redeclared. When we use the variable names within the method in which it is declared, the variable takes precedence over any other variable with the same name in another method. We can say locally declared variable always mask or hide other variables with the same name elsewhere in the class. In this example, we have a class overriding variables, and this class has a 3 method: main, first method, second method. And each method, they have their a number, right? In the main, we have an integer a number equal 10. So this a number is declared in main. In the first method, we have an integer a number equals 77. It is declared in first method. And in the second method, we also have a parameter integer a number. Those variables, although they share the same name, a number, but they are different variables because they are declared at a different memory address. They are only known to their blocks they are declared. Let's take a look at method overloading. With method overloading, multiple methods can have the same name with different parameters. So instead of defining many methods with different names that should do the same thing, we can use overload method. In this example, we overload the plus method to work for both integer and double arguments. So the first plus method has two arguments, both are integer, and it returns integer result. For the second plus method, we have two double arguments and it returns the results double type. Inside the main function, when the arguments are integer type, so the compiler will use the overload method with the integer arguments. So integer my number 1 equal plus method A5. When the arguments is double type, the compiler will decide to use the overload method with a double argument. So double my num2 equal plus method 4.3 and 6.26. Overloading methods have the same name but with different number of parameters or different data type of parameters. A constructor in Java is a special method that is used to initialize objects. The constructor is called when an object of class is created. It can be used to set initial values for object attributes. Java automatically provides a construct method when class is created. We can also provide programmer-written constructors. Constructors can take no parameter or take parameters. In this example, we have a two programmer-provided constructor. The first employee without parameter, right? It's a defaultly set the employee number to 999. The other constructor, employee, and take one parameter, so the user, the client, can set the employee number when the object is created. So the client just passed the parameter. So constructor can receive parameters. It's used for the initialization purpose. If a class-only constructor requires an argument, you must provide an argument for every object of the class that you create. Those two constructors are also overloading methods, right? They have the same name but different parameter. Let's take a look of this keyword, THIS. This keyword refers to the current object in a method or constructor. The most common use of this keyword is to eliminate the confusion between class attributes and the parameters with the same name, because a class attribute is shadowed by a method or constructor parameter. In this example, we have a public class main, and it has a variable integer x. In the constructor, we have a parameter x, and inside the constructor, we have a x equal x, so we assign the x to x. So actually, we are assigning the parameter x to the parameter x, right? Because inside the constructor, the x, local x, has the precedence over the x in the class main scope. When the object, my object, is created and we pass parameter 5, but actually the system.out.print the value of x equal 0 because the x in the class main is not changed. So this constructor does nothing. The class data field is not changed. So here we use this.x equal x. So this means we are assigning the parameter x to the data field of the class x. Now the class x is changed. So if we have a pass parameter 5 for the constructor, the system.out.print line will output the value of x equal 5. Using this reference to make overloaded constructors more efficient, In this example, we have an overloaded constructor. Student, and there are several parameters. The first constructor is a integer double. Second constructor receive a double parameter. And the third one has an integer parameter, and the fourth one has no parameter. So instead of writing in this way, we can reduce the amount of a repeated code in the writing in this way. So we use the this reference from one constructor version to call another version. So for the first constructor, we still have an integer and a double. Then for the second constructor, it only receives one double parameter. So we can just say this, then we pass the first parameter integer 999, and the second parameter the double type. For the third constructor, only receive one integer parameter, so we can use a this reference, and we say we pass the integer number for num, and we just pass 0.0 for the second double parameter. And for the constructor with no parameter, we just say this, and we pass the initialization 999 and 0.0. Recall in chapter 3, we learned that if you use a static for method, we can use the static method without creating objects. So static method belongs to the class. Static methods don't have a this reference because they have no object associated with them. Therefore, they are called class methods. We can also create class variables, which are variables that are shared by every instantiation of a class. That means shared with every object of the class. In this example, we have a baseball player class. The baseball player class contains a static field named the count of players, and the two non-static fields named the number and the batting average. The baseball player constructor sets values for number and the batting average, and increase count of player by 1. In other words, every time a baseball player object is constructed, it contains individual values for number and the batting average. But the count of players field contains a count of the numbers of existing objects and is shared by all base player objects. The show player method in the baseball player class displays a baseball player's number, batting average, and a count of all current players. The show player method is not static. It accesses an individual object's data. Methods, if you declare as a static, cannot access instance variables. But non-static instance methods, such as showPlayer, can access both static and instance variables. The testPlayer class in the bottom is an application that declares two baseball player objects, displays them, and then create a third baseball player object and display it. When you examine the output, you can see that by the time the first two objects are declared, the count of plays value that they share is 2. Whether count of players is accessed using the A catcher object or the A shortstop object, the value of count players is the same. After the third object is declared, its count value is 3, as is the value of count associated with both of the previous declared objects. In other words, the count of player variable is increased within the instructor. So its value changes with each new instantiation, and because the field is static, Each object has access to the single memory location that holds the count of players' value. No matter how many baseball player objects are eventually instantiated, each refers to the single count of players field. In Chapter 2, we learned to create named constants by using keyword final. Sometimes a data field in a class shall be constant. For example, you may want to store a school ID value that is the same for every student object you create. So you declare it to be static. In addition, if you want the value for the school ID to be fixed so that all students' objects use the same ID value, for example, when applying to scholarship granting organizations or when registering for standardized tests, you may want to make the school ID unchangeable. We can use a static final keyword. In this example, the class contains the constant school ID in static final. Because it is static, all objects share a single memory location for the field, and because it is final, the value cannot be changed during program execution. A non-static final field's value can be assigned a value in a constructor, while a static final field's value must be set at the declaration. They cannot change in the constructor. You already have used several of pre-written classes. For example, we have used the system and the JOption pen classes to produce output. Each of these classes is stored in a package or a library of classes, which is simply a folder that provides a convenient grouping for classes. Java has two categories of packages. The java.len package is implicitly imported into every program you write. The class contains fundamental classes that provides the basis of a Java programming language. All other Java packages are available only if you explicitly name them within your program. The class java.len.math contains constants and methods that you can use to perform common mathematical functions. All math methods are static, so you don't need to create objects. You can just use a math, which is a capital M, math dot, for example, ABS, then you pass the parameter. So math.abs, the parameter, will return the absolute value of x. Java contains hundreds of classes, only a few of which are in the java.len package, which are included automatically in the programs you write. To use any other pre-written classes, you must use one of the three methods. Use the entire path with the class name, or you import the class, or import the package that contains the class you're using. You can use the asterisk as a wildcard symbol, which indicates that it can be replaced by any set of characters. For example, the following statement imports the local date class and any other java.time classes as well. Java local date class is an immutable class you cannot change that represents date with the default format of YYY-MMDD. In this example, we can create two local date objects with the current date and the May 29th, 2020 using the following statement. Local date today equal local date dot now. Local date graduation day equal local date dot of 2020, then 5, then 29. These statements use the static methods now and of respectively. We can see the static method because they're used with the class name, and without an object. And the now method accepts no arguments, and the off method accepts 3 integers that represent a year, month, a day. They return the local date type and assigned to the local date object. The two system.out.println line display the local date object, and we can see they are string type. They separate the year, month, and the day by dash. They are methods that allow you to add and subtract time from an existing date. In this program, it prompts a user for a furniture order date and displays details about the delivery day, which is 2 weeks later. So here, order date dot plus weeks, then weeks for delivery. Weeks for delivery is a constant 2. So plus weeks, this method will add 2 weeks to the order day. The composition is a design technique in Java to implement a has-a relationship. Java inheritance is used for code reuse purposes, and the same we can do by using composition. The composition is achieved by using an instance variable that refers to other objects. If an object contains the other object, and the contained object cannot exist without the existence of that object, then it is called composition. In more specific words, composition is a way of describing reference between 2 or more classes using instance variables, and the instance should be created before it is used. When you use an object as a data member of another object, you must remember to supply values for the contained object if it has no default constructor. For example, you might create a class named name and address that stores name and address information. Such a class could be used for employees, customers, students, and anyone else who has a name and address. So this figure shows a name and address class. This class contains 3 fields, all of which are set by the constructor. So in the constructor, we set name, address, and the zip code. And then we have another method, which is a display method, displays the name, address information on 3 lines. In this figure, we can see we have a class school. The class school has an instance of name and address. We have a private name and address, name add. The school class constructor requires 4 parameters. Within the constructor, 3 of the items, the name, address, and the zip code, are passed to the name and address constructor to provide values for the appropriate fields. The 4th constructor parameter is assigned to the school class enrollment field. Composition allows reuse of code. It represents a has-a relationship. In composition, both the entities are dependent on each other. When there is a composition between 2 entities, the composed object cannot exist without the other entity. The composition is achieved by using an instance variable that refers to other objects. In Java, it is possible to define a class within another class. Such classes are known as a nested class. They enable you to logically group classes that are only used in one place. Thus, this increases the use of encapsulation and creates more readable and maintenance code. The scope of a nested class is bounded by the scope of its enclosing class. Thus, in this example, the class house data is nested inside the real estate listing class. You usually will not want to create inner classes. For example, if you made the house data class as a regular class, as opposed to an inner class like this, and you store the house data class in its own file, you could use it with a composition in other classes. So you probably will not create nested class frequently, but you will see them implemented in some built-in Java classes.